You know the ice cubes in your drink, the water you're sipping, the very air you're breathing. They all seem completely different, don't they? But what if I told you they're basically all just different versions of the same exact thing? Well, today we're going to dive into the really cool world of the states of matter and figure out the secrets that connect them. All right, so first up, let's talk about solids. Just look at these ice cubes. They've got their own shape, their own size. Super rigid, right? They hold that form no matter what, whether they're chilling in a glass or just sitting on a table. Okay, so next we've got liquids. Now, these are different. Unlike solids, liquids don't really have a fixed shape. They just kind of flow and take the shape of whatever you put them in, just like this water filling up the glass. And finally, we've got gases. Gases are literally all around us, but a lot of the time you can't even see them. They don't have a fixed shape, they don't have a fixed volume, they just expand to fill whatever space they're in, kind of like the steam coming off this pot. So you have solids, liquids, and gases. They all seem so different, but like I said, they're all just different forms of the same thing. So, what is the secret? What connects them all? Well, that secret ingredient? It's matter. Yeah, matter. It's the physical stuff that makes up, well, everything in the universe. We're talking from the tiniest little atoms all the way up to the biggest galaxies. Okay, so what exactly is matter? Well, put simply, it's just anything that has mass and takes up space. And it's all made of these incredibly tiny particles, atoms and molecules. And here's the kicker. The way these little particles are arranged and how they move around, that's the entire key to understanding why we have solids, liquids, and gases. To really get a handle on this, let's use a pretty fun analogy. I want you to imagine that all these tiny particles are like students at a school. Seriously, how they act throughout the day, it's a perfect way to picture the different states of matter. All right, you ready? Let's jump right in with our first state, solids. So, when you've got a solid, the particles are just packed together, super tight, like sardines in a can. They're basically locked into this rigid structure, and all they can really do is just vibrate in place. And that's why solids have a definite shape and volume. Think back to our school analogy. It's like students sitting at their desks in a classroom. They might fidget a bit, but they aren't going anywhere. Okay, let's move on from the classroom and see what happens when things start to, flow a little. Let's talk liquids. Now, with the liquid, the particles are still pretty close together, but, and this is the big difference, they're not locked in place anymore. They've got enough energy to just slide past one another. And that's exactly why liquids can flow and take the shape of their container. Back to our school, it's like the bell rang, and the students are in the hallway between classes. They can move around each other, but they're still stuck inside the school building. All right, and now for the state of matter that's everywhere, all around us, but most of the time we can't even see it. Let's talk about gas. So in a gas, the particles are way far apart, and they're just zipping around at super high speeds, going in every possible direction. They have so much energy, they just completely break free from each other and expand to fill literally any container they're in. It's like the final bell at school, right? The students just pour out of the building and scatter everywhere. Okay, but here's where it gets really cool. These states, solid, liquid, gas, they're not permanent. They're not set in stone. Matter can actually change from one state to another, and the secret ingredient to make that happen is energy. Usually, we're talking about heat. In water is the absolute perfect example of this. So, you take some ice, right? You heat it up, its little particles get more energy and start vibrating faster and faster. Eventually, they break free from that tight, rigid structure, and boom, the ice melts into liquid water. If you keep adding more heat, those particles go even crazier, moving faster and faster until they finally escape completely and turn into a gas. But what if matter decides to just skip a step? It can happen. There's a process called sublimation, and that's when a solid turns directly into a gas, totally skipping that liquid phase. The most famous example of this? Dry ice. It's just solid carbon dioxide. It doesn't melt into a puddle like regular ice. It just sort of vanishes into a spooky cloud of gas. Now, because dry ice is so cool, and I mean that literally, it's about negative 109 degrees Fahrenheit, we absolutely have to talk about safety for a second. This stuff is cold enough to give you some serious frostbite, so please never touch it with your bare hands. Always use gloves or tongs. And another huge one, never ever lock it in a sealed container. As it turns into gas, that gas builds up a ton of pressure, and the container can actually explode. All right, so we've got solids, liquids, and gases, and that covers most things pretty well.
But what's really fun is that some substances, well, they just don't like to follow the rules.
I mean, the world isn't always that black and white, is it? So is it possible for something to be a solid and a liquid at the same time? Believe it or not, the answer is yes. And these things are called non-Newtonian fluids. They're these super weird substances where their thickness, or viscosity, changes depending on how much force you put on them. The classic example is oobleck, and you can totally make this at home with just cornstarch and water. And someone explained its weird behavior perfectly. If you just pour it, it acts like a liquid, but if you apply force to it, it acts like a solid. Think about that. If you slowly dip your hand into a bowl of it, it feels all gooey and liquidy. But if you punch it or squeeze it fast, it instantly gets hard, just like a solid. It completely breaks our neat little categories. Okay, so let's just sum all this up real quick. Solids. They've got a fixed shape and volume because their particles are locked down. Liquids. They have a fixed volume but take the shape of their container since their particles can slide around. And gases, no fixed shape, no fixed volume because those particles are totally free to just fly around everywhere.
The takeaway here is that matter is constantly changing all around us. And hey, sometimes it doesn't even play by its own rules. So the next time you see ice melting in your drink or watch steam rise from a kettle, take a second and think about it. What's really going on with all those tiny particles? What other awesome secrets is matter hiding from us, right in plain sight? Keep looking, stay curious.